Okay, so let's see if we can continue on here. There was one example that we did. Let's try another example, and this time I'm going to get you to just pause the video, obviously, when I have the example up. So here we go. I'm going to draw another triangle on here, orient this one a little bit differently. Okay, so how about if we said that I had this angle up here was 55 degrees, and I'm going to tell you that this one over here is 12 meters, and we're going to put our variable here. So what I'd like you to do is I would like you to solve for x in this scenario. So go ahead, pause the video now, and give it a whirl, and then unpause it when you are good to go. Okay, well, welcome back. So here we go. First step, we're going to put our theta on the angle we know or we want to know. There goes my theta right there. And then we're going to label off our sides. H is always the easy one to find. Here's my H. O is opposite to where my theta is. There goes my O. And adjacent is the leftover side or the side that's attached to the theta that is not the hypotenuse. So there we go. We're going to write out our H, O, A, and theta. And we're going to fill in the bits that we know. Well, as it turns out this time, we've got no H, so it doesn't get to play. O is 12 meters. A is going to be x, and theta is 55 degrees. So we're going to write out our SOHCAHTOA again to help us decide which primary trig ratio it is that we're going to use. There's my SOHCAHTOA. And I see that I have O and A, and obviously the ratio that's got O and A is tan. So what we're going to have here is we're going to say, all right, well, that means that we're going to have the tan of theta equals the first letter, which is O, over the second letter, which is A. So O over A. So I'm going to fill in those values. So we have that the tan of 55 degrees is equal to O, which is 12, over A, which is X. So there we go. That's like, approaching half of the marks just to get it set up like this. But again, here's what we're looking for. It's in the denominator. So I'm going to do this one both ways. I'm going to show you the traditional, full steps. So I'm going to multiply both sides by x to clear the x out of the denominator, and to keep the equation balanced, I have to multiply this side by x over here as well. Those guys are going to go away. And then I'm going to have x times the tan of 55 degrees is equal to just 12 now. And I want to get x by itself. Currently, it's being multiplied by the tan of 55. So I'm going to divide both sides by the tan of 55. So I'm going to divide by the tan of 55. Those are going to go away, and we're going to end up with x equals, and we're going to grab our calculator, and we're going to type that in. We're going to say, okay, calculator, it is, again, making sure that our mode is degrees. We have that it's 12 divided by the tan of 55. So we type that in, and we're going to have 8.40. So we know now that x is actually 8.40 meters. Okay, so that's the full way, and I'm happy for you to continue doing it like that. But I can show you a way that's a little bit more expedient, a little faster. So if we had the tan of 55 equals 12 over x. So we're in the exact same position again. Basically, we're going to skip the step where we multiply both sides by x. We know that in the long run, it's going to end up being x is equal to 12 over the tan of 55. So when what we're looking for is in the denominator, we can kind of, it's not really cheating because we know what it's going to be, but we're going to skip an intermediate step. We're going to say, I know that those two are going to end up in the reverse position. So we're going to have x equals 12 over the tan of 55. Okay? And so it ends up being the exact same thing. It just saves us the hassle, not really hassle, but the extra step of multiplying both sides by x. So again, if what we're looking for is in the denominator, we can simply swap the position of the denominator and the trig expression that we've got on the other side. Okay, so let's do one more of those for some practice. And then what we're going to do is we're going to look at cases where what we're looking for is in the third potential position, which is, of course, inside the actual angle. So I'm going to just draw a really quick triangle here. Let me do a bigger one like this. And I'm going to say that this side, that looks to be 20 centimeters. And this angle here, I don't know, how about 15 degrees, and I want to solve for x. So go ahead, pause the video, try this one out, and then come back in a moment. Okay, welcome back. So what we've got going on here is, first step again is we're going to put the theta on the angle we know or the angle we want to know. So here's my theta right here, because recall we're not allowed to put our theta on the right angle. And then we're going to label off our sides. Well, this side is H, so there's my H. O is opposite my theta, so my O goes over here, leaving this side to be A. So we're going to write out H, O, A, and theta. H, O, A, and theta. We've got that X is there. O, well, O doesn't get to play here. A is 20, and theta, well, it is 15 degrees. So we can look at SOHCAHTOA again. SOHCAHTOA. And we can see, oh, we have A and H, right? Those are the variables that we have left over. So A and H means we are going to have to use cosine. So that means it's going to be the cosine of theta is equal to A over H, first letter over second letter. So A over H. So we've got then the cosine of 15 degrees is equal to adjacent, which is 20, over hypotenuse, which is x. So there we are. We're in that same position again, where what I'm looking for is in the denominator. So what I'm looking for is in the denominator. I can either clear the denominator by multiplying both sides by x, or I can recognize, oh, I know in the long run that these two guys are going to end up switched in position. So I'm just going to make that shortcut. I'm going to say, oh, that means that x is equal to 20 over the cosine of 15 degrees. Okay, so I can go ahead, I can grab my calculator and I can type that in. So we're going to have that x is equal to 20 divided by the cosine of 15 degrees, which we find out is 19.32 centimeters. So we've got that this is 19.32 centimeters. Okay, so there are three examples of when we're looking for a variable and it ends up being in the denominator, which is great, not bad. So now we're going to go on to the final variant that we can get for primary trig ratios. And so the final variant is when we're looking for the variable is the angle. Okay, so when we're looking for the variable as the angle, it is the third scenario, although the cookbook recipe stays the same for almost all the steps right until the very end. So draw a really quick triangle here. Here comes a triangle. That's a beauty right there. There's my right angle. How about we look for the small angle down here? I'm going to put my theta down there, or a variable. Let's say it was x. Why don't we do that? We'll put that actually as x. Okay, x. So that's the angle I'm going to want down here. And it doesn't really matter which two sides. How about we say that this is 20 kilometers, and this side looks to be, if that one's 20, this one's maybe 16 kilometers. Okay, so we go through our cookbook recipe again, and our cookbook recipe says the first step is put the angle on the theta on the angle we know or we want to know. Well, here is the first scenario where it's the angle that we want to know. Again, even though we know this angle, our theta is not allowed to go on the right angle. So we're going to put our theta on the angle we know this time. So there's my theta. Okay, so the step is put it on the angle we know or we want to know. I want to know the angle. My theta's got to go there. So then I'm going to label off my sides. As always, H is easy to spot. O is going to be opposite my theta, so my O goes over here. And adjacent is the leftover side, or the side that's attached to the theta that is not the hypotenuse. Okay, so then we're going to list out our sides, H, O, A, and theta. And we're going to fill the bits in, and we're going to say, all right, well, my H hits 20. O, in this case, nothing going on there, so it doesn't get to play at all. And then A is going to be 16. And theta, well, theta is what I'm looking for, so it's x. So I'm going to list out my SOHCAHTOA again. SOHCAHTOA. And then I'm going to say, oh, I've got my A and I've got my H, so that puts me back into the cos field. So it's going to be the cosine of theta equals A, which I'll put as first letter over second letter. So that means that it's the cosine of this case, it's going to be x is equal to A, which is 16, over H, which is 20. Okay, so this is good. So there is, about a third to a half of the marks, depending on what all's going on in the problem, just to get this set up. So we know how to solve when my variable's in the numerator. and we know how to solve my variables in the denominator. We haven't yet in this class done any examples where what I'm looking for is in the theta. So here's what we're going to have to do. Right now, cosine is being operated on by, x is being operated on by cosine. Cosine is an operation. Very much in the same way that x squared equals 12, squared is an operation on the x, and the opposite operation would be square root. Cosine is an operation on the x, and so the opposite operation for that is going to be cos inverse. So what I'm going to do is I'm going to cos inverse both sides. And again, I'm going to show you with more detail than what I expect to do in the long run. But I'm going to say, all right, well, I'm going to do cos inverse of this whole side, which is going to be the cosine of x, is equal to, well, if I cos inverse this side, just like up here I had to root both sides, down here I'm going to have to cos inverse both sides. So we're going to have the cos inverse of 16 over 20. And the cos inverse of the cosine of x, well, those are inverse operations to each other, so they undo one another. So on this side, I'm left with just x. And on this side, well, that's just something I can type directly into my calculator, which I'm going to do right now. I'm going to grab my calculator and say, all right, I have an expression that says it is the cos inverse of 16 over 20. So again, you're going to have to know how your own calculator works. If you have a calculator with brackets that you can type in and you can see everything that you've typed in, you're just going to type in second function cos to get access to our cos inverse. And we're going to type 16 divided by 20. 16 divided by 20. And again, we have to make sure that our calculator is in degrees, which I know mine is. And so I have found this angle. This angle turns out to be 36.87 degrees. So I'm going to go back here and say, all right, this is lovely. This is 36.87 degrees. Now, revisiting this calculator. If you have a calculator that's only got one line of display and it kind of doesn't show you the operations that are going on, you're going to have to do what's inside the brackets first. So if you have a one-line calculator, you'd have to type 16 divided by 20, press equals, and then do second function cos inverse, and it will automatically tell you what the answer is, and you should be able to get 36.87. Okay? So let's try another one of those. I'm going to put a couple more examples up, and what I'd like you to do, of course, is to pause the video and try them yourself. So I'm going to draw another triangle here. Let's try and do it with straight lines this time. Here we go. Straight line, straight line. And I'm going to tell you that this time, I'm going to say, I don't know, this angle down here is maybe the one I'm interested in. I'm interested in the larger angle. So I'm going to say, I'd like you to solve for angle X. And I'm going to tell you that this side is 3, and this side looks to be, how about 15, and make those meters in both cases. So go ahead, and I'd like you to solve for X, please. Pause the video. All right, welcome back. So first step in our primary trig ratio solutions is going to be, we're going to put a theta on the angle we know or want to know, not on the right angle. So here goes my theta. There it is right there. It's on the angle I want to know. I'm going to label off my sides. H is always easy to spot. There's my H. O is opposite, and adjacent is the leftover side. I'm going to write out the sides. H, O, A, and theta. So there's my H, O, A, and theta. And I'm going to fill everything in. Well, H doesn't get to play. O, well, it's 15. A, well, it's 3. And theta, it's X. So I'm going to write out my SOHCAHTOA again. SOHCAHTOA. I'm going to say, oh, I got O and A. Well, with O and A, means we have to use tan. So I'm going to write that out. So it's always in the form tan theta equals first letter over second letter. So O over A. And I'm going to fill out all my knowns. So I have the tan, in this case, it's going to be X is equal to O, which is 15, over A, which is 3. And so I want to get the X all by itself. Right this very moment, we have that tan is happening to the X. Well, the opposite operation of tan is, of course, tan inverse. Now, I could write tan inverse in over here. So imagine that I said, all right, I'm going to be fastidious about this. I'm going to do that this is the tan inverse of that side is equal to the tan inverse of this side as well. Go back and make that black. Is that black? I think that's black. And so the tan inverse of the tan of X, the tan inverse of 15 over 3. And obviously the tan inverse of the tan of X is going to be X equals, and then I would type that in. I'm going to show you, I don't expect you to do the tan inverse on both sides like that. What we can do is after we're in this position, so we've got the tan of x equals 15 over 3. I don't expect you to write the tan inverse on both sides, although you are welcome to because that is the complete form. What I just expect you to do is I can say, oh, well, that means that x is going to be equal to the tan inverse of 15 thirds, because I know that the step after this, the tan inverse and the tan, are inverse operations to one another. So I'm going to end up with just x. So I'm happy for you to go just from here to here. So I kind of think about, I'm not moving it the other side, but it's going to end up on the other side, and it's going to end up being a tan inverse. Okay, so then I can grab my calculator and I can type in what is the tan inverse of 15 thirds. So where did my mouse go? Hello, mousey. It's going, oh, my pen's on the table, that's why. So we're going to do, come back here, the tan inverse, second function, tan inverse of 15, that's not going well, 15 divided by 3. Type that in, and we're going to find out that that angle's got to be 78.69 degrees. So I'm going to come back here and say, oh, that means that x is equal to 78.69 degrees. Okay, so there are a couple of examples of solving for theta. We'll do one more final example that you can practice with here. Draw this out. Okay, so let's solve for the smaller angle this time. Here's my theta, and I'm going to say that maybe this time is, this side is 5 and this side is 13. So I'd like you to go ahead and solve for the unknown angle here. I made it easy. Obviously your theta is going to go there. Okay, pause the video, finish that one off. Welcome back. So what we've got going on here is my theta is going to go on the angle I know where I want to know. Well, I kind of screwed up when I put the theta there, so I know that's got to be my theta. List off my side lengths. This side's got to be h because that's my theta. This side's got to be O, and this side is A. So list out H, O, A, and theta. I know that my H is 13, my O is 5, and my theta, well, the A doesn't actually get to play. My theta is, well, it's theta. So I'll just say it's theta. So I've got O and H. If we look back up, I know that's going to end up being the sine of theta equals opposite over hypotenuse. So then I'm going to fill those values in. So I've still just got the sine of theta equals opposite, which is 5, over hypotenuse, which is 13. So I can just skip right down. I know it's going to end up being theta is equal to the sine inverse of 5/13. So I'm going to grab my calculator. Here it is. And we're going to do the sine inverse of 5/13. And we're going to find out that that unknown angle is 22.62 degrees. So I know now that theta is equal to 22.62 degrees. And there we go. Okay, so that's that. I'm going to put up some questions on Google Classroom for you to practice. And thanks for joining me.